Electric dipole. An electric dipole consists of a pair of equal and opposite point charges separated by some small distance. Here we have two equal and opposite point charges separated by some distance, so they form an electric dipole. The total charge of the electric dipole is equal to minus q plus q equal to 0. This means the total charge of electric dipole is equal to 0. The middle point of location of charge minus q and plus q is called the center of the dipole. Now dipole moment. The dipole moment is a measure of the strength of electric dipole. It is represented by P. It is a vector quantity whose magnitude is equal to the product of the magnitude of charges and the distance between them. So P will become 2ql because it is the multiplication of the charge and the distance between the charges. The direction of P is from negative charge to positive charge, and the SI unit of electric dipole is coulomb meter. Now we will discuss about the field intensity on axial line of electric dipole. Okay, let us consider an electric dipole consisting of 2 point charges minus q and plus q separated by some small distance 2l. We have to calculate the electrical field intensity E at P on the axial line of dipole. If E1 is the electrical intensity at P due to charge minus q at A, and E2 the electrical intensity at P due to charge plus q at B, okay, then we know that the distance between two charges is 2l, that is AB equal to 2l. If O is the center of the line AB, then OA equal to L, OB equal to L. Let the distance of the point P from central point O is R, then OP equal to R. Okay. The distance of AP will become R plus L, and the distance of BP will become R minus L. Okay. The distance of AP will become R plus L, and the distance of BP will become R minus L. Okay. Okay. The direction of E1 will be towards A, and the direction of E2 will be outwards from the D. Why? Because for positive charge the field lines are radially outwards, and for negative point charge the electric field lines are radially inward. Since it is a negative charge, so the direction of E1 will be towards A, and since it is a positive charge, so the direction of E2 will be outwards from the B. Okay. The value of E1, that is the electrical intensity at P due to charge minus q at A, will be 1 by 4 pi epsilon naught q R plus L whole square. And the value of E2, the electrical intensity at P due to charge plus q at B, will become 1 by 4 pi epsilon naught q R minus L whole square. Now, as E1 and E2 are collinear vectors, it is clear that it is collinear vectors acting in opposite direction. And E2 is greater than E1. Why E2 is greater than E1? Because its denominator is less than the denominator of E1, and the term whose denominator is less than the term other denominator, it will become larger. So its denominator is less than this denominator, so it will become larger. So E will become E2 minus E1. The net resultant field intensity will become E2 minus E1. We will write the value of E2, that is 1 by 4 pi epsilon naught q R minus L whole square, 1 by 4 pi epsilon naught q R plus L whole square. We will take q out. We will take q by 4 pi epsilon out, then it will become 1 minus R minus L whole square minus 1 by R plus L whole square. We will take the LCM, R minus L whole square, R plus L whole square. This term will cancel each other, and the term R plus L square will come here, and R minus L square will come here. Okay. Q by 4 pi epsilon naught A plus B whole square. The formula will come, and it will become, okay, and here it will become R square minus 2RL plus L square. Okay, again we write this. We will open the bracket. R square plus L square plus 2RL minus R square plus 2RL minus L square, and this will become, okay. Now this will cancel each other, and this will cancel each other. Please note that we can write R minus L whole square, R plus L whole square as R minus L into R plus L into R plus L. Okay, we can write this term as A square minus B square, so it will become R square minus L square, and we can write this also as A square minus B square, that will become R square minus L square. So it becomes R square minus L square the whole square. So we can write this as this. So it will become Q by 4 pi epsilon naught 4RL upon R square minus L square whole square. Okay, since R is very large than L, it means that L is very small than R. L is very small than R, and here it is L square, so this term will become very much small, so we can neglect the L square. So we can write E equal to Q by 4 pi epsilon naught 4RL R square whole square. It will become Q by 4 pi epsilon naught 4RL R 4. Now I will do here, okay, Q into 4RL 4 pi epsilon naught R into RQ. This R and R will cancel. We can write 4QL 4 pi epsilon naught RQ. We can write Q into 2 into 2L by 4 pi epsilon naught RQ. But we know that P equal to 2QL. 2QL will become 2P and 4 pi epsilon naught RQ. This is the derivation of field intensity on axial line of electric dipole. Now in the next class we will discuss about the field intensity on equatorial line of electric dipole. Okay, thanks.